Welcome to Eagle Complete course. In this video, I will give you some tips for you to do your project on Autodesk Eagle. The first tip is to change default units. The Eagle default measurement unit in my software is mils. I actually more familiar with millimeter unit. So, how do we change the default setting of measurement unit in Eagle? First, open the Eagle control panel. Then, click the script drop-down and select the script subfolder. You will find a file named eagle.scr. Double-click to open it. Now, you can see some text code here. Go to the board or BRD settings. Since I want to change the default measurement unit for the board layout editor, below the BRD text, type grid mm. Then, add the semicolon. You can do this to the schematic editor as well. Just scroll down until you find the schematic text. Here, it returns with grid default. You can change the default text to millimeter or mm. The next tip is command history. When you create your schematic design in the Eagle schematic editor, you will notice that beside the Add Part icon, there is a small arrow. It contains your recently used component and allows you to quickly recall a recently used component instead of open the Add Part window and search from the beginning. The list of components inside the command history will always renew every time you use different components. Then, the next tip is trace width. When you route your PCB design, sometimes you need to change the size of the wire. There's a simple and quick way to do that. Here, for example, I have a very small routing wire. And I want to make the wire size to 0.8 millimeter. Instead of change it manually, you can easily type here on the command line the size you desired, then press Enter button on your keyboard. And it will automatically change the size of the wire. You can always do this every time you need to change the wire size. The next is single layer view. On the top part of Board Layout Editor window, you will see this icon here. It is a single layer tool. It will help us a lot when we work with multiple layer PCB. This tool provides us the capability of only seeing the active layer. So, if this tool is enabled, every time we switch layers, that layer going to be the active layer, and all the layers' opacity will be turned down. So your screen will be looking like this. The next tip is fan out command. Eagle has a tool called fan out command. This command will automatically draw a short trace out of an SMD pad and places a via at its end. There are two modes of fan out command. The device mode creates the fan out for all SMD pads of selected device. Then in signal mode, all SMDs of all devices in the layout that are connected to the selected signal are taken into consideration. The icons in the parameter toolbar of the fan out command let you choose the operating mode and decide about how the vias should be placed. Whether via inside or outside of the SMD device, or alternating. In Eagle version 9, the fan out command has a new allow violations mode that allows to place vias although it might violate the design rules. This mode helps in tracking down the reason when fan out can fail for some vias. The next one is schematic components placement on net. Usually, when we have a component to add in the wired net, we have to delete and redraw the connection. But in Eagle, we no longer have to delete the existing net, place the component, and redraw the connections. We just have to place the components in the net, and Eagle will automatically reconnecting the net. The next one is Object Inspector. Either in Schematic Editor or Board Editor, when you click the View menu on the top of your screen, you will see the Inspector option. It is recommended for you to activate the Object Inspector since it will ease the process of editing the value, the direction, or any parameter of your component. The Object Inspector allows you to run Eagle commands that are specific to the objects in your selection. And it will also adjust to show what function can be applied depending on how your selection filter is set up. For example, when I click on the switch component, here on the quick action we can see that the tools that can work in this component are delete, attributes, change value, replace part with another device, rotate, and mirror. Then, when I select the wire or the signal connection, the only tool that can work on them is only the delete command. The next tip is defining filters. Filters allow for precise and dynamic selections of design object based on name, values, attributes, and other properties. Each filter is a combination of filter criteria combined into logical expressions using and or operators. The filter composer offers an interface to create filter expressions. Filter expressions can also be created or shared in text form. Filter can be saved in a design or across designs, and both in schematic and in board. Detailed help on filter criteria and valid syntax and operations is available in the Eagle directly in the Design Manager's filter panel. Then, another tip is to use the meter commands. Basically, miter command has two types: the straight miter wire and the round miter wire. You can see here, using the round miter wire, you can make your connection become round like this. You can simply do this by click the left button of your mouse and drag the wire in. Then, by using the straight miter wire, you can make an angle like this to your connection with the same way as before. Another tip I can give you is IPC Wizards. So IPC Wizard provides users to make their own 3D package. This tip actually explained in the previous video, but I will tell you again how to do it when we start from the Library Manager. So, for example, here I choose the library of a component. Open it in the library editor. Then, in the 3D package column, here on the bottom, you can click the Import 3D package, then select Create with Package Generator. The IPC window will appear, and it comes up with some package of components you can use. You can adjust the size, dimensions, and positions parameter of each 3D package component. Then, for the next step is to use your mouse effectively. When you're designing your PCB using Autodesk Eagle, there are many practical uses of the mouse in Eagle CAD. More than using it as pointer. First, you can use it to change the layer using the scroll button. Let's say you are routing PCB. A lot of people used to change the layer of an object using the Layers drop-down menu. However, by using the mouse, you can change the layer by pressing the scroll button. Second, you can use your mouse to change the wire bend style. You actually can change the wire bend style by selecting these options here on the upper toolbar. But we can use the easier way by clicking the right button of your mouse. Next, the roughness tip. You can use the roughness tool to see how many numbers of unrouted wire. By pressing the roughness, Eagle will show the number of unrouted wires in the bottom left corner of the board layout editor. This feature is very useful for double-checking that you didn't miss any air wires. Especially since sometimes you may not notice them when searching visually. The next one is to hide any unrouted wires. When doing a routing process, I usually route the ground signal at the very last of the process. So, sometimes the ground unrouted wire is very annoying while I route the other tracks. But you don't have to worry, because we can hide certain signal by using roughness command in the line command. The command is roughness Then, add the exclamation mark behind it, as you can see on your screen. And if you want to hide the ground signal, then you can add GND behind this command. Or maybe if you want to hide another signal, like VCC for example, just write VCC behind this command. Then, to make it visible again, you can write this command. It is almost similar with the previous command, but write it without the exclamation mark. Then, I will tell you how to turn polygons off. So, when we have drawn a polygon, a power polygon for example, then we need to change some routes. Whenever we click Resonance, the polygon will fill the PCB again. Actually, you can keep working without polygons until you want to enable them again. Without deleting them, you can just turn them on or off as you like. To turn polygons off, select Rip Up tool, rip up polygon, then write this command in the command line. Set poly off. Then, to turn them on, type this command. Set poly on. In this video, other than tips about how to work with Eagle, I will give you some tips related to electronic circuit. First tip is to leave enough space between traces. It's important to leave enough room between all of the traces and pads on your PCB layout. Why? If you pack things too close together, then you'll run the risk of short circuit developing when your board gets manufactured and traces unintentionally connect. The Autodesk Eagle recommends you to always leaving a gap of 0.007 to 0.01 inches or approximately 0.178 to 0.254 mm between all adjacent pads and traces on your board. The next tip is to avoid using 90 degrees trace angles. I might have talked about this tip in other videos, but I want to make a bold line in this tip. I suggest you to not using 90 degrees trace angles. When you have a bunch of traces that have a sharp right angle turn on your board, the outside corner of that 90-degree angle has the likelihood of being edged narrower than your standard trace width. And at its worst, you might get a bunch of 90-degree traces back that aren't fully etched, that resulting in shorts. As a solution to this problem, try to use the 45-degree angle traces. This will produce some beautiful PCB layouts while also making your manufacturer's life easier by being able to easily etch away all of the copper on your board. The next one is to make your power and ground traces wider. Not all of the traces on your PCB layout are created equal, and you will want to make sure that you increase the width of your traces that are going to serve as your power and ground path. Why? Both power and ground traces will have more current flowing through them. And if you don't make them wider than average, you'll have a ton of heat trying to flow through those skinny spaces, which can end up burning wires and ruining your board. By making your power and ground traces as thick as possible, you will also be able to quickly recognize them if you ever need to review and make adjustment to your design in the future. Then, we suggest you to use VS to remove heat. VS are not only ideal for providing electrical connectivity between layers, but they're also the perfect tool to use when you need to move heat from one side of your board. This comes in handy if you ever need to channel heat away from one of your super-powered components, like an integrated circuit or IC. By placing multiple VS below the die of an IC, you'll be able to lower the operating temperature of a component. Which will, in return, make your design all that more reliable in the long run. Next, even though I made a lesson about the Autodesk Auto Router, I suggest you to not fully rely on this feature. Auto Router is indeed an easy way to solve our routing problems. But As good as outer router can be, they are never a replacement for routing yourself. There are some conditions or reasons where you should only use the outer router. First is the precision. You can use the outer router after you place all of your components to see what completion rating you get. If it's below 85%, then this is an indication that you need to make some adjustment to your part placement. Second, bottlenecks. You can also use the outer router to discover bottlenecks and other critical connection points that you might not have seen during your component placement process. And the last is inspiration. You can use the outer router as a source of inspiration for how you might want to route some traces that you just can't complete. A quick run through the outer router might show you a new path that you hadn't considered before. Outside of these three reasons, I'd recommend not relying on your outer routing to complete all of the routing on your board layout. The other tips I want to say is for you to figure out the trace width. When you have electricity coursing through all of your copper traces, it's going to produce some serious heat. And this is always a concern with electronics. Controlling the width of your traces is one of many ways to reduce how much heat builds up on your board. And the wider your traces, the less resistance that electricity will encounter when flowing through your circuit. To determine the thickness of your traces, you can use the trace width calculator like this one from Advanced Circuit that will allow you to plug in your estimated current and thickness and get a trace width value in return for internal and external layers. Here, you can enter the current flows through your circuit. Then they will calculate the trace width best for the internal layers and the external layers of your PCB. Here, you can change the measurement unit at the drop-down in the right side of the column. The values written here are mostly the minimum width that is considered safe for the amount of current. So, it's even better if you use larger width than what the calculator recommended. After you're done making PCB design, you will most likely to manufacture them. So, it is better for you to understand your manufacturer's specification at first. Before you start laying down a copper trace, first, take the time to give your manufacturer a call or shoot them an email to see if they have any specification requirements on minimum trace width, trace spacing, and the number of layers they can handle on a board. Why? By knowing this information upfront, you can set your trace width and spacing values in your design rules and avoid having to reroute your entire board layout down the line. And by using trace width and spacing that your manufacturer can produce, you'll make everyone's life easier when it comes time to make your board. For example, I'm going to open the PCBWay and the GLC PCB web. On PCBWay web, go to the product and capabilities. And here, you can see tables showing their specification in manufacturing PCB. On GLC PCB web, go to the Capabilities menu. And they also provide their PCB specification. If you take a look at these both manufacturer's specification, some of them have the same specifications, even there are also a few differences. I think that because they're both a big PCB manufacturer. But if you compare to the small PCB manufacturers industry, they may be not as detailed as these two companies. So, always make sure your manufacturer's specification on making PCB, because not all manufacturers have the same capabilities to do the same specifications. The last tip I want to add in this video is when you do the component placement on your PCB, make sure you separate the analog and digital components. The purpose of this is to help minimize the common return path for analog and the digital signal. Here, I will mention some considerations when separating analog and digital sections. The first one is sensitive analog components such as amplifiers and voltage references are recommended to be placed within the analog plane. The second, if a system contains one mixed signal analog to digital converter or a digital to analog converter with low digital currents, this can be treated similar to analog components that are included in the analog plane. Then, the third, for designs with more than one ADC and DAC with high current, it is recommended to split the analog and digital supplies. And the last one, microprocessors and microcontrollers may take up some spaces and will generate heat. These components must be placed in the center of the board for better thermal dissipation, and at the same time, close to their related circuit blocks. So, here are some tips of working with Autodesk Eagle. I hope you understand well about this course.